Okay. Uh, okay. For the three cannibals, three missionaries who need to travel to the other side of the river bank. So for the problem, I'm gonna use BFS as well as DFS, two different methods to solve this particular question. So the basic flow of my solution is basically my main program takes input from the file where the first value is the missionaries, the number of missionaries, the number of cannibals, and the third one is the maximum people who can travel in a boat. Okay, so main function is pretty much taking the input from the file, and I have declared two functions to run BFS and DFS separately, and also output them into a different files. Um, yeah. So before I move into the implementation of BFS and DFS traversals, different traversals. So what I did was took these inputs, named them into a constant. Uh, so basically this constant dot py is like a constructor for naming these variables as missionaries, cannibals, and um, people who can travel in a boat. Okay, so coming to the BFS implementation, so it's a standard implementation which I did, where I considered all the possible states of this problem, three missionaries and three cannibals. So all those states are considered as nodes in my program implementation. Uh, so how the BFS is going to work for my program is, so all the nodes, they are considered not visited in the not visited, like as in visited is the visited is an array which puts all the visited states in it. So the things which are not in the array are not visited. So for each not visited branch, I'm gonna visit all the children, like all the explore, like all the nodes that need to be explored in that particular level. And then once all the nodes in that particular level are visited, then I'll go to the next level, to the next level, to all the children again. So over here what happens is, if there are, let's just say there are A and B are two nodes whose root is C. So, and A has other two children known X and Y. So my program does not explore the node X until the node B is explored. So that is the implementation of BFS I have used. And on the other side, I have DFS. So DFS, it is also like the standard implementation where I uh, parse the one side of the tree as far as possible until and unless I need to backtrack to the other node. So over here, what it does is, to the previous example where the structure of the tree is C being the root, has A and B as the children, and A has X and Y as the child nodes, leaf nodes, let's just say. So in the DFS, what happens is, at first, the visited array is empty. Visited node array is empty. So once I start with the root C, the visited array is appended with C. So this C is again, we need to, since it is in visited, the next state I'm gonna visit is A. So in the state A, I'm gonna push this onto the stack because we're gonna go into a particular direction of the tree. So I'm gonna push A onto the stack after C, and then after A, I'm gonna have X pushed onto the stack. Once, if X is not the terminal state, I'm gonna pop X since X does not branch further into other nodes, or like it has any other subtrees. So I'm gonna pop X from the stack and then push Y to the stack since it is the other um node or other child of A. So once I again check the terminal state of this particular program, that is all the three cannibals and three missionaries should be on the right side along with boat on the right. So um, yeah. So once my so like parallelly the visited nodes get updated with C, A, and X, and once X is popped, the X is still will be present in the visited node. However, once X is popped, Y is placed inside the stack, and if Y is the terminal state, the program terminates, giving the output as the number of nodes that are explored. In this case are C, A, X, and Y. That is 4 out of 5 nodes those are present. Uh, and if it is in the case of BFS, if Y is the terminal state, the number of explored nodes are 5 out of 5. Yeah. So over here, in the BFS, what we're gonna use is a queue where we're gonna append all the nodes which are visited at a particular depth of the tree. While in DFS, we're gonna push the nodes which are visited and are currently the parents of the node we are visiting in the stack, and we'll check if it is a valid state or not. In our case, if we check it is in a valid state or not, and or a terminal state, either valid state or a terminal state, and then pop each one of the invalid states out, and then check if it has any other siblings or a similar subtrees on the other sibling node, and we're gonna traverse that part, and then similarly pop the invalid nodes out while traversing through it. So this is pretty much the implementation which I've did. So let's just run the program for three cannibals, three missionaries, and two people can travel in a boat. So that is going to give me as we took an example of the tree with C as the root and AB as its child, and A having two other nodes X and Y. So if Y is the desired terminal state, then when it is a BFS, when we implement BFS, the number of expanded nodes and explored nodes are the same, since if we were to explore Y, we need to expand till Y because it is in the second layer, I mean second, let's just say height of the tree H2 at Y. So when it comes to DFS, it is not the case because the nodes in the example I have taken, the nodes we have are 5. Though we have 5 nodes which are explored, but expanded nodes are just 4, because at the fourth node we found the terminal solution, and our the program is terminated. Uh, yeah.